Okay, you're asked to solve this system of three linear equations and three unknowns using Gauss-Jordan elimination. I'll send you a link to this online site where you can solve a system using Gaussian elimination. But I just want you to notice the notation here. Here's the augmented matrix, where these are the coefficients of x, y, and z respectively, and these are the constants. And then this notation tells you what you're allowed to do, or what operation you're performing to get from this matrix to this matrix. And on board 2, I have a list of the operations that you're allowed to do that doesn't change or it leaves you with an equivalent matrix. You can interchange any two rows and you still have an equivalent matrix. A row can be multiplied or divided by a non-zero constant, and a constant multiple of one row can be added to another row. And our goal is to take this matrix, which says that 5 times whatever x is plus 2 times whatever y is will give us this number right here. And similarly for the second and third rows. So our goal is to transform this using those operations that were on board 2 into something that looks like this. And then this says 1 times x plus 0 times y plus 0 times z equals whatever number I end up with right here. So that will be the value for x. Okay, so here's the original matrix. I don't have, pretend this is scrap paper, and I'm just trying to get an idea of what's going on. So I'm not indicating the operations that were performed, but I could say to get from here to here, I interchanged rows so that the smaller number was up here. Okay, that's not necessary, but that's how I like to do it. If you divide every element of this row by 2, you'll get the 1 here that we're looking for right here. And then if I divide by 2 every element, that's what that new row becomes. The second and third rows remain constant. Now what am I going to do? I'm going to try to get zeros for those 2 elements. So I'm going to leave row 1 all by itself, or not change it. So when I'm working this out on scrap paper, that's what I do, is I copy this row down, realizing I'm not going to change it. Then I'm going to multiply this row by -2 and add it to the second row. And that will get me a 0 right here. And so when I take -2 times 1/2, I get a -1. Add it to the second row, that's where this 2 came from. And -1/2 times -1/2, I'm sorry, -2 times -1/2 is 2, is 1. 1 plus -1 is 0. And -2 times 0 is 0. 0 plus 3 still gives you the 3. And then at the same time, I'm going to multiply row 1 by -5 and add it to this row. And this is what I get. Now we've got zeros here. Our next goal is always to get this element to be 1. We want to work down this diagonal. So if I divide every element of this second row by 2, I'll get 0, 1, 0. 3 halves. And now I'm ready to leave this row intact and convert these to zeros. So if I multiply row 2 by -1/2 and add it to the first row, I'll get a 0 there. And that's what I've done. And by the time I get to this last row, the only thing that's left for this row is to multiply everything by 2/5 so that I get a 1 here. And 2/5 times 11/4 is 11/10. And similarly, the last thing to do is to get this to 0. Multiply row 3 by 1/2 and add it to the first row. And there's your answers right there. Because this is X, Y, Z. Okay, there you go. I'll send a link to the Gaussian elimination calculator so you can give it a shot. If you have any questions, post a comment.